Hi all and hello Professor. We are Team Data Warriors and we are here to present our final project case study, which is how does a bike share navigate speedy success. So here is the list of all my teammates: Mahesh Ravi, Maheshwar Reddy, Siri, Venkatayappa Reddy, Divya, and myself Vishwa. So let's
Hello,
start about
Professor.
the company.
Yeah. Hello, Professor. This is Mahesh, and today I'm going to explain this side. Like, first of all, what is about the company? And this is about a bike share company in the Chicago city. And in 2016, Cyclistic Co. launched a successful bike share offering. Since then, the program has grown to a fleet of 5,824 bicycles that are geo-tracked and logged into a network of 692 stations across Chicago. And the bikes can be unlocked from one station to and returned to any other station in the system anytime in the Chicago city. And cyclistic sets itself apart by also offering a recycling bikes, hand tricycles, and cargo bikes, making bike share more inclusive to people with disabilities and riders who can't use a standard two-wheel bike. And the cyclist company have a two types of bike users. One is casual riders, and next one is annual members. And the cyclistic directors of marketing believes the company future success depends upon the maximizing the number of annual memberships. Coming to the next slide. The next slide is nothing but about objective. The cyclistic director of marketing believes the company future success depends upon the maximizing the number of annual memberships, and therefore your team wants to understand that how casual ride different from member rides. From these insights, core team will design a new marketing strategy to convert casual riders into annual members. Coming to the next slide. This slide explain about the data where we have a sample snapshot of data files in the formation. These are the different Excel files, and this is a public data that we can use to explore how different customer types are using cyclistic bikes. From this analysis, I have considered data from March 2011 to February 2022, and this data set was arranged into 12 monthly separated files in CSV format. Altogether contain 4.9 million plus data rows, and each CSV contains about a zero point 0.5 million to 1 million records and 13 attributes. Those attributes are like end underscore late and n underscore LNG and end station ID, and these are all. And my friend Divya will continue from the next slide.
Hello everyone, these are the tools used in our project. Below are the tools used as part of the case study as per the objective description. One of which is a Google Colab. Colab or Collaboratory allows you to write and execute Python in your browser with zero configuration requirements, access to GPU free of charge, and easy sharing. The other one is Microsoft Excel, which is used for data analysis quickly and for sanity checks and to glance the data. Data loading. The total data has about a 1 GB storage. Due to the local system hardware constraints, we approach Google Colab for further any development platform. The data is located in G Drive in archive format, and simply we extract all 12 months of data. We mounted the G Drive to our Google Colab notebook in interact with data files. Now the next task would be to verify the data integration. For that, we planned a quality, which will provide a high level insight about the data. Slide represents the overall high level picture about the data by performing data integrity. The code snipped for the scene is available in shared IPYNB notebook. This is the column available which has the these are some of the column names and description of it. Some of them are end underscore lat, which means latitude of the destination, and underscore LNG, which means the longitude of destination, and member underscore casual, which means customer who purchased annual membership are celestic, and customers who purchase single ride or full day passes. Coming to star slash LAT, it is latitude of source. Start slash LNG, which is the longitude of source. Start slash underscore station underscore ID, which is the source or star station ID. These are some of the column availables. From now, my friend is going to continue.
Yeah, hi, this is Ravi. So today I'm going to discuss about the data integrity of data integrity checks. 1 second. Yeah. So coming to here, like we can see the column name and the rows. So here that like end lat and end long and end stations and at, these are the columns and the rows comes like uh, descriptions, data mine, total rows and total nulls, and these are the data which have we gathered like in these projects. And coming to the next slide, the distributions in the data, like there are some problems in the like provided data set, and and about the four attribute have some missing informations, and we imputed them in the mode value of respective columns, and removed like 146 row is identified as a fall recorded start at the end. Those records are represented at a past travels and ideally ended should be greater than the started, but it is a vice versa. About like 13 percentage data being removed due to the empty latitude and longitude values, and for three stations like a station name were missed, and using the lookups from the database we imputed the stations and named for these three stations IDs, and we have like mentioned here what are the station names and the station IDs, and there is no outliers presented, and the same has been proven by the verifying and quality reported provided. So coming to the next slide, here the station IDs and station names are not be considered, and like both these snap shows that both start stations and the end stations, like so many stations are fell under the stations IDs, which is strange, and the stations IDs having a different length values, and they are like they are plain alphabets, and some are the numeric. And coming to the like data set informations, like bike sharing systems are the new generation and the traditional bike rentals, like user is able to easily rent a bike from the particular positions and the programs. Apart from the interesting real world applications of a bike sharing system that categorize data being generated of these state systems. So no, so my friend is going to continue the next.
Hi, my name is Sirisha. So I'm going to explain the data cleaning steps. So check for the missing data and imputed missing values with their modes and data type conversions. Checked for the null values and duplicate records, validity of data range, removed invalid records, and the consistency of categorized values, organized and saved clean data, and remove the records which has incorrect start and ended values. So then we have data some extra values and we adding some extra uh, records, so we can use data cleaning steps. We remove all the duplicate records. So next slide please. So future engineering, as part of future engineering we derived some of the attributes from existing values in data such as ride length and ride length in seconds, in minutes, in hours also, day of week and start of month, start of the year, start of the hour. So some of the examples are we, we are seen here. So next slide please. So monthly rights trend. So we are seeing in this graph January, February, March, June, July, August. So July, August and September months are the mostly popular users month. So I'm going to hand over this presentation to my friend. He will explain.
Hi, hi to everyone. And here the ride duration in hours. Here in graph, you can see the ride length in minutes. Here we are calculated ride length more than 2 hours. You can see this graph, how the ride length is in minutes. And next, here ride type distribution. Here you can see the member and casual. Here this one x-axis shows which type, like member and casual, and the y-axis shows right member, the hours. Here you can see the 55.70% of customers are opted for an annual membership. And here you can see that 44.29% of customers are not opted for the annual membership plan. Still they are in the casual membership. In the graph, you can see clearly. And coming to the next slide, here you can see the right type, right duration with respective to the right type. Here in the casual members are traveling more than compared to the annual members holders. On an average, 22 minutes being traveled by the casual members, whereas 12 minutes traveled by the annual members. Means there is a 47% more casual members are showing interest to use these services. In graph, you can see the right duration with respect to the right type, the members and the casuals. Here, casuals are more the using than annual membership holders. Thank you, and my friend will continue then.
Hey, hi everyone. Myself, I'm Venkatayappa Reddy. Here I'm going to discuss about this graph. The first graph comes under weekdays usage trend. Here we have plotted a graph between average ride duration and weekdays. Coming to as shown in the graph, we can see like more rides have been taken on Saturdays. Especially the blue line indicates the casual rides, and the orange line represents the membership. Coming here, we can see like more rides have been taken on Sundays, and annual memberships users has been taken on Saturdays. Coming to next slide. Coming to this graph consists of like a hourly comparison. On it is a between like a average duration of each ride versus hours. Like we can see the blue line indicates the casual line, and orange line indicates the membership. Compared to the annual members, casual members are using commute from 7 a.m. to 7 p.m. like 5 p.m. Sorry. Coming to next slide. This graph is for a hourly comparison. It is between like a start on a y-axis we can see each station names, and on x-axis we can see total number of rides taken per week or for each day. Coming to this graph, blue line indicates the casual member, and orange line indicates the membership. Coming to result, like a total area shown to use this advertisement strategies since more rights have been taken place. Coming to next slide. Recommendations: implement a new annual membership tier at low price point where a total number of rights are allowed for a given time of period, for example like a week or a month, and versus a current annual membership structure for like a unlimited number of rights. For like a maximum time will be like a 45 minutes per each ride, and given on average casual rides spend more time on the rides than current members, but on average only 1480 seconds have been taken place. Implement a limited time promotion for annual membership that loses limits on Friday, Saturday, Sunday rides given on those most important popular days. Casual rides are cyclist bikes. Added more electric bikes to inventory given casual ride prefer them over classic bikes. Launch a marketing campaigns in summer from June to August. From here, Vishwa gonna continue.
So before going to the conclusion part, we would like to show our code and the working demo done. So we have done it using our Google Colab notebook. And firstly, we have imported all the data, the CSV file we got it from the Kaggle website, and we have loaded all the data, all the CSV files. So with all the data sets, we have merged all months of data into a single data frame. So this shows all the number of rows and attributes given. So these are all the attributes, which include the ride ID, end station, start station, the time, and everything. So these are the total records, and there are a total of 13 attributes. So this is a sample data from the data gathered after combining it into a one CSV file. So next comes the data integrity check report. So we have also implemented this, and this gives us a quality report preparation of what it actually does and the quality of the data set or the work that is implemented here. And we save that report into a CSV file. And first comes data cleaning. So we have used all the missing value imputation part, and we have done the data cleaning process. And these are our observations. So the first thing was the start station name and the ID. Null values are not matching. And we have imputed the missed station names and rest of the IDs. And moreover, the location data using the mean mode or the median, since it's geographical data of latitudes and longitudes, which doesn't make any sense. And we have excluded those records that are non-geographical information. And these are all the missing columns for few of the data available. And we have removed all that. And this was our final data after we have done the cleaning process. And these are all the examples and how much, the start station names and start station IDs as well. And these are a couple of examples of all the clean data. And this gives our final result. And we have grouped all the data available. And this is an example of the start station name and the IDs. So from this, we have seen that there is a clear inconsistency in the station IDs and station names. So many stations are fell under the station IDs, which is a little out of work. And station IDs are having different length values. So some are plain alphabets and some are numeric. So this is a final check of data cleaning. And coming to data wrangling. So first we have gathered all the data type conversations, and most of them are just the object values or the float. And of course we have the data time framework, which are the values of time. And we have done our feature engineering part, and these are all the observations. And moreover, we have calculated the length of the ride and which days of the week and which year it was greater or lower and all. And we have used the lambda function here in the data wrangling part. And these are a couple of example graphs of total rides taken per every month. And it's in that observations, we have found that both the weekends are the most rides, where the most rides have been taken. And if we see that further, it is different with respect to the membership types, which is the casual and the annual memberships. And this graph depicts the month and the total rides taken, where we can find that the July month was the highest. And as we have said earlier, July, August, September months are most popular usage of the rides. And we have removed all the records where ride length is negative, which we found them as a false data. And the aggregation part, we have done the descriptive analysis. And these are all the count and standard. The ride length was calculated, and that's a plot for this. And moreover, we have done the data wrangling and the ride membership distribution with respect to the type of the rider. and these are its observations, and we have calculated the average length, right? And with respect to both the casual members and the annual members. And we have also calculated the mean and minimum value and maximum value for both the customers, which means the casual or the annual membership. And this is a graph of the ride duration available and membership casual with respect to all both types of the customers. And this is the average ride length for user for in a day by day week. And moreover, this is a graph that represents, as we have already mentioned, the average ride duration in the weekday. And these are all things, and the recommendations for the plotted, I mean, the plotted data, which is with both the casual and annual members. And these are all the recommendations part we have done. And these are graphs that differentiate between both the casual and the annual members. And this is our work done. And coming to the conclusion part. So we have performed various tasks that include data loading, data wrangling, data cleaning and aggregation, and the plotting of the available data, which is our Capstone project of bicycle share navigate speedy success data we had. And all the data has been studied and been plotted, which are now shown before in the Google Colab environment. So that's all about our presentation and our project. And thanks for this opportunity.
Thank you, Professor.